This is a video on dividing with dealing with exponents and also negative exponents, and then I also talk about an exponent of 0. Okay. All right. So, first rule: if something is raised to the 0 power, it is equal to 1, no matter what it is. So you can have this number like 23. It's a small number. If it's raised to the 0 power, it equals 1. You have this big long number raised to the 0 power, still equal to 1. You could have a fraction or a decimal, and that's still going to be equal to 1. This is the only weird situation. 4.2 to the 0 power, that is 1. But outside, lurking outside, was this negativity, right? This negative sign. So this becomes negative 1. Okay, that's the only thing that's different. So the rule is that if anything is raised to the 0 power, it equals 1. You could have a big, long problem like 16, x to the second, y to the negative 3, z to the fourth, and then 2, x to the negative 2, y to the fifth, z to the 24th. I don't know, it doesn't even matter. If it's all raised to the 0 power, it equals 1. Doesn't matter what's in here. If the whole thing is raised to the 0 power, it equals 1. Okay. So this is just to illustrate how negative exponents work. You will see a pattern here. So 2 to the third is 8, 2 to the second is 4, 2 to the first power is 2. Anything to the 0 power is 1. Now 2 to the negative 1 is going to be 1 over 2. 2 to the negative 2 is 1 over 4. 2 to the negative 3 is 1 over 8. And you see the pattern here? 2 to the negative 2 is 1/4. 2 to the positive 2 was 4. See how it's a fraction flipped. It's what it is with the 1 on top. Okay, so let's look at some examples here. So, 2 rules here. You never leave a negative in an exponent in your answer. So when you get down to your answer, it cannot have a negative sign in it, okay? So all of these are not done, not simplified yet. If you have a negative exponent in the numerator, that's up here, and it's negative, you want to move it down here to the denominator to make it not negative anymore. So see this negative 3? I don't want that to be negative 3. I want it to be a positive 3. So what do? I move this whole thing down 2 to the third power. And then the 5 was already there. I'm not going to move it or change it or anything. When you have everything in the bottom and you've got nothing on the top of your fraction, you have to put a 1. Okay, you can't just have a bottom of a fraction running around by itself without a top. That's silly. Don't do that. 2 to the 8th power, or 2 to the third power is 8. And so altogether this equals 1 over 40. You can put this into Desmos, type it in exactly as it is, and it will give you the answer. It's when we're dealing with these variables, now you're going to have to really understand the rules. But it's worth looking at and understanding the rules just for numbers, even though you can type things into calculators. So 3 to the negative 2 power. I don't want this to be a negative 2. I want it to be a positive 2. So what do I need to do? If this is in the numerator, I got to move it down to the denominator. See how it became positive? All I did was just move it down. Okay, it's like trading places. And now we can say this is 1 over 9. Okay, when we have a power rule, which just to remind you, x squared raised to the third power. The power rule says you multiply those two, and that gets to be 2/6, okay? So same thing happens here. We're going to apply this exponent to both things, to both the top and the bottom. Okay, so 1 to the negative 2 power over 3 to the negative 2 power. Now I can't have negativity, right? So anything in the upstairs is going to move down. Anything in the downstairs is going to move up. So 3 squared over 1 squared and then simplify further. That's 9, and that's 1. So your answer is 9. Okay, I guess I could have drew boxes around all my answers. There's no real math to do there, but you're not allowed to have this negative sign in here. So this just ends up being 1 over x to the third. Okay? It was in the upstairs, so it moved to the downstairs. That's it. Okay, this is to illustrate a point. I don't think we need to do all of them. I don't know. Anyways, so 2 to the 6th power means 6 2's multiplied together. 2 to the 3rd power means 3 2's. Then what we do when we simplify, if you have something on the top and the bottom, you can cancel them out if they're the exact same thing. So exact same thing. And now I'm left with 3 2's, 2 to the 3rd power. Okay, works the same for this guy. You have 1, 2, 3, 4, 5 over 2. I cancel the ones that I can. If I have 1 on top and 1 on bottom, I can cancel it, and I'm left with 4 to the 3rd. Then it works the same with variables. 1, 2, 3, 4, 5, 6 over 2 of them. Cancel 1 on the bottom. Cancel 1 on the bottom, and I'm left with 4 of them. And kind of need my picture to move out of the way. Just get rid of it. Okay, now you can see this problem, y to the 3rd over y to the 7. So, oops. Okay, what? Oh my goodness. There. Y, and y, 3 of them. This is called expansion. When you take an exponent and then you actually write them all out, that's called expansion. Y to the 7. So 1, 2, 3, 4, 5, 6, 7. Now on all these other examples, we ended up with more of them on top than on bottom. This is different, right? So we get rid of 1 on top, 1 on bottom, 1 on top, 1 on bottom, 1 on top, 1 on bottom. What I'm left with is 4 y's on the bottom. Nothing on the top. Remember, you can't have a fraction with just a bottom. That's crazy. So you got to put at least a 1 up there. All right, so this is your answer. But you could also get this answer in a different way, because this is how you would get it with the expansion method. Then there's also the rule, which is x to, say, the 5th over x to the 2nd is equal to x to the 5th minus 2nd power, so x to the 3rd. So this is the rule, and this is the expansion method. You can pick whichever you want. Come over here, see how it works. 2 to the 6 minus 3 is equal to 2 to the 3rd power. Yes, that's the same answer. 4 to the 5 minus 2 power is 4 to the 3rd power. Yes, got the same answer. X to the 6 minus 2 power is equal to x to the 4th. Bam, same answer. Y to the 3 minus 7, order matters with subtraction, right, is equal to y to the negative 4. Now this goes back to the negatives, right? What do you do when you have a negative exponent? You got to move that thing. So I move it, and it becomes 1 over y to the 4th. Okay, so all these different things are kind of connected, especially when you're thinking about the division and then the negative exponents. Okay, I'll put that in the trash. Okay, so here's some more examples. So all you have to do here is get rid of the negativity in that exponent. This, if there is no bottom to a number, that means it's in the numerator already. So this becomes 1 over x to the 5th. Done. Okay, over here, let's think of all these things are in the top right now. You're only going to move things that have a negative exponent. Okay, so then I'm going to leave the 7 where it is. It doesn't have a negative exponent. Yes, it's a negative number, but that's okay. That has nothing to do with a negative exponent. And here you go, simplified. Okay, please excuse this line here. It just got captured in when I was trying to copy and paste these from a worksheet. Okay, you've got this power to a power situation. So you've got to, it almost looks like distributive property, sort of. Got to distribute that to everything that's in here. So I have 3 to the negative 2 power, and I have x to the negative 6 power. Remember, those are in the top. To get rid of the negativity, what do? I move them to the bottom. Then, if you can simplify a number that has an exponent, you should do that. So this is not a good way to leave the problem. You should say 1 over 9 x to the 6. There's nothing you can't simplify when you don't know what the variable is equal to, but you can when it's a number. Okay, I have a negative 2 up here. This one's positive. So this one's just going to stay where it is. It's not going to change. But I've got to move this k to the negative 2 and put it down here, and k to the 7th. So now I have k to the 9th power, and can't have a fraction without a top. So put one on there, okay? All right. Okay, we'll do this example. So this is pretty similar to one of the other problems that we just did. I'm going to apply this negative 2 exponent to everything in here. So 5 to the negative 2, y to the negative 4 is equal to 1 over 5 squared and y to the 4th. Got to get rid of the negativity. That's why I moved it downstairs. Is equal to 1 over 25 y to the 4th. Okay. Now, this is a good problem to do in the expansion method. 1, 2, 3, 4. 1, 2, 3, 4, 5. 1, 2, 3 down here, and 2 right there. And now I'm going to use a different color to cancel them out. So I cancel, 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 cancel. Cancel, 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 cancel. What am I left with? I've got only one x up there and 3 y's. And that's my final answer. Now, if you wanted to do the other method with the subtraction, you would do x to the 4 minus 3, y to the 5 minus 2. And so x to the first power, y to the third power. And that would be how you got that answer. Okay. What you need to do, though, is be really careful if you're going to use this method. Make sure that you're subtracting the bottom exponent from the top. So 4 minus 3, not 3 minus 4. Because if you get a negative exponent, you're going to be moving things, da, 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 da. That's why I like the expansion method better for that problem. Okay, deal with the numbers like you've always been dealing with numbers. Negative 16 divided by 4 is negative 4. Then I have 1a and 4 b's over 3 b's. So let's cancel what I can. I don't have any a's down here, so I have to just leave the a. But 1b, 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 1b. Okay, and so I'm left with negative 4ab. Now, since everything canceled under here, I mean, you could say over 1, but why would you? It doesn't serve any purpose for you. You only put a 1 under it when you need something to be a fraction, and this is simplified on its own. Okay. Okay, another couple of examples. When you have two things that are to the same power, so b squared and b squared, really you could just cancel them both out, okay? But again, I'll just show you the expansion method. So b, b, and a c, and a b, and a b, and 5 c's. 1, 2, 3, 4, 5. And I can cancel, 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 cancel. And that leaves me with just nothing on top, so you put a 1, okay? And then 4 c's. So that's my final answer. But if you like the subtraction method, it would look like this. b squared minus 2, right? And then c 1 minus 5. See, this is the weird situation. These cancel out. B to the 0 power is just equal to 1, right? But c to the negative 4 power, now you got to change that and make that 1 over c to the 4th. And that's why I don't like this method as much. I think this is much clearer. 1 times this is just itself, so 1c to the 4th. So that's what I mean by they're canceling out. Really, they're turning into a 1, which doesn't change anything, and so we just leave it off. Okay. I deal with the numbers just dividing them or simplifying them if they can't divide into, like this is 9 is divisible by 3, but say you had a situation like 12 and 8. Okay, if you had 12 and 8, well, 12 is not divisible by 8, but you can reduce this. They're both divisible by 4, so that can turn into a 4. A 3 over 2. Okay, so you reduce the numbers, either divide them if they're even like that, or reduce them. So 9 divided by 3 is 3. But then I still am going to do the expansion. 1, 2, 3, 4, and then 1, 2, 3. And then down here, 10 of them. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And then 7-wise. 1, 2, 3, 4, 5, 6, 7. Come over here and cross out, 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 cross out. So I end up with 1, 2, 3, 4, 5, 6. 6 x's on the bottom. Over here, cross out a y, cross out a y, cross out a y, cross out a y. Okay, and that left me with 4 y's on the bottom. So 3 is still on the top, and then x to the 6th and y to the 4th. And hopefully you can see that that makes sense. Like really what you're saying is, what is the difference between these two exponents? So 6 is the difference. But does the difference get awarded to the bottom or to the top? Okay, that's another way to think about it. If you don't like the drawing everything out. Okay, what's the difference between these two numbers? 4, and who had the biggest exponent? So the bottom had the biggest exponent. That's why it keeps the exponent. It's just another way of thinking about it. It's not the most mathematical way, but it is true. Okay, another example. All right, 4, a to the negative 1. So I'm going to start putting things down here that need to go down here. B to the 5th, that can stay up here. C to the negative 3, it's got to go down here. Then the whole thing is raised to the 3rd power. So this 3rd power goes to everything. Oops, I meant for that one to go this way. Everything in here. Like there's 4 different things in here, and they're all getting this exponent of 3. So 4 to the 3rd power, b to the 15, a to the 3rd, c to the 9th. And the only thing that you can simplify here is this 4. 4 times 4 times 4, that's 16. And then times 4 is 64. So 64, b to the 16, a to the 3rd, c to the 9. Okay, now this next problem. See this 4 here? See how these are different? This belonged to everything in there. The 4 only belongs to what's up here. So I'm going to apply it, 2 to the 4th and y to the 20th over 10 and y to the 15. Okay, this is where it gets a little ridiculous to draw out all the y's. Okay, so then we want you to start understanding the method here. Also, let's simplify this 2 to the 4th power. Okay, that's 4, so this is 16. So we've got 16 y to the 20 over 10 y to the 15. Simplifying these two numbers, they're both divisible by 2. So we've got 8 over 5. then who has the most y's, the top or the bottom? Top does. By how many? 5. So y to the 5th. And that is done. And so is this video.